Good afternoon, listeners. In this series of Azure Site lectures, we will discuss today MAC protocol. Now, let us first discuss about these two words. First is MAC, another is protocol. Now, before we move further, we have to understand that computers nowadays, they have to communicate with each other or the devices or amongst themselves, and they have to use some communication mechanism so as to transfer data from one device to the other, send it and receive it. Now, this is going to be something like a traffic. For example, we have one road and multiple vehicles are moving in that road. So what would happen if there are no rules and regulations? For example, one of the foremost rule is, especially in India, we have to drive on the left hand side of the road. So that is a protocol. So that is a rule. So this rule ensures that the chances of the errors or the chances of the accidents, they are minimized. Henceforth, similarly, in our computers also, since there is going to be a lot of communication between one computer and the others, in both ways, sending the data as well as receiving the data, and there are going to be some intermediate devices as well, like routers, switches, servers, and so on and so forth. We have to adhere to some rules and regulations so that the data is safely sent. Safely means it is sent in an intact form. That means its integrity is not lost, and it has to be safe in terms of its security and authentication, and it has to be consistent. There could be some delays, there could be some errors, but that has to be within a stipulated limit. So, protocols is definitely a set of rules and regulation which the participants or the stakeholders, they have to adhere to make the process or the system efficient or workable. Now, coming down to that, first that was protocol. So that definition of rules and regulation, that holds true in our computer networks as well. Then we have MAC. MAC is medium access control. So medium over here is the communication channel which is going to be used for a communication of data between two devices, digital devices. This could be a medium access control, and some literature also say this as a multiple access control. So why this multiple? Multiple means more than one device, and definitely at least two are involved in a communication. More than two devices, they are going to use the same channel, and hence they have to adhere to some rules and regulation. So this basically MAC is a set of rules and regulation which is responsible for framing MAC address and control every packet. So the data is traveling in the form of packets over the network, and these packets, they have to be suitably addressed to target to the receiver, and it has to be framed. So MAC is a sub-layer of data link layer which also has data link control, which is responsible for error and flow control. So basically, MAC sits below a data link control, and it is responsible for framing and MAC address and multiple access control. This is the primary responsibility. Now, what do you mean by multiple access? As we discussed, as in the case of a road is there, one road. So of course there could be multiple lanes, but this is essentially one way or one road, and there are going to be multiple vehicles. So that's the same over here, something like that. When two or more nodes transmits in the same time, their frames will collide, and the link bandwidth is wasted during collisions. That's something like the same. If there is a unfortunate accident on the road, the whole traffic is delayed besides some losses. So that is the first point of multiple access. Two or more nodes transmit at the same time, and the probability is if proper protocols are not followed, then the frames may collide, and hence loss in communication and also loss in bandwidth, capability to transmission, that is also wasted. So we need a protocol to coordinate the transmission of active nodes. These protocols are called medium or multiple access control protocols, and they belong to a sublayer of data link layer called MAC, that is medium access control. Now, these multiple access control, the task is to minimize collisions in order to utilize the bandwidth. So these protocols, like the traffic rules, what's the objective of the traffic rules? The objective of the traffic rule is to minimize collisions, that is accidents, in order to utilize the highway in the best possible way. So this highway, in this case, utilization is utilize the bandwidth. Now, what are the subparts of this? It determines when a station can use the link. Now, if you are entering a highway, you have to wait for the traffic on the right. So you have to determine that when a particular vehicle enters the road, you cannot just start the car and just enter the vehicle. If you do so, of course, you're going to attract some penalties or losses or some accidents, not desirable. Now, over here is to minimize the collisions, it has to be determined that when a station can use the medium, and this medium, it could be a twisted pair of copper wires, it could be optical fiber, it could be a wireless, or so on and so forth. It could be Bluetooth and so on. Now, what a station should do when the link is busy? So what we do when you are trying to take your vehicle on the road and the road is busy. So what we do? We wait. How long? Depends upon the protocol. For example, one protocol is traffic on the right has the right of the way. So what the station should do when it is involved in a collision? So there could be two probabilities. Either the road is empty, so no issues, just enter, use the road, or what a vehicle, or in this case a station. Station in this case is a node, a computer node, which is intending to participate in data communication. And what it should do when the link is busy, and what the station should do when it is involved in collision. So these are the three aspects of medium multiple access control. So we have three categories of these protocols. Like in the traffic, we have multiple categories of protocol. So we have some categories of protocols over here. First one is random access protocol, another is controlled access protocol, and third one is channelization protocols. Right. So these are the three basic categories. And in random access protocols, we have Aloha, CSMA, and CSMA-CD, CSMA-CA. And in controlled access, we have reservation, polling, token passing, and in channelization, we have FDMA, TDMA, and CDMA. Before we move further with Aloha, CSMA, and different flavors of CSMA with CSMA-CD and CSMA-CA, let us briefly discuss about the channelization protocols. For example, this is a protocol, this is equivalent to multiple lanes on the highway. So this could be the probability. So you have multiple lanes. So of course your lane is not wide enough now. If it is 60 feet road, two lanes has been created, so you're going to get 30 feet, not 60 feet. So this is frequency division multiplication or time division multiplication and channelization, three issues. So we'll discuss these one by one. First is random access protocols. In this random access protocol, no station is superior to another station and none is assigned a control over another. If I try to take an example, for example, if you see a car coming on the highway with the red beacon on this, or so that means, fortunately or unfortunately, we assume, or the users of the road use, that the particular car is superior to the other cars and has the right. But Other way speaking, if there is a fire brigade which is coming or an ambulance which is on the way, then it is the duty of all citizens or the road users to give the right to the fire brigade or the ambulance and so on and so forth. So, they are superior. So, in random access, such superiority or this is not taken into consideration, and in this what happens is a station with a frame is a packet of data and a station is a node, a computer. It is to transmit it can use the link directly based on a procedure defined by the protocol to make a decision on whether or not to send. So, we have no reservation is there, no prioritization is there, and that is just a random protocol, that is it. But there has to be procedure which is defines a protocol to make a decision on whether or not to send. So, that is we will discuss about this protocol shortly. Then there is Aloha protocol. It was designed for wireless local area networks and can be used for any shared medium. In pure Aloha protocol description, this is the issues involved. All frames from any station are of fixed length. So, packets of the data they has to be same sized. Stations transmit at equal transmission time, maybe after every 1 second, every 1 nanosecond or whatever the regulation is. And a station that has data can transmit at any time. If they have got a data, they can transmit at any time. Now, after transmitting a frame, the sender waits for an acknowledgement. So, you have to wait for an acknowledgement for an amount of time equal to the maximum round trip propagation delay. So, how long you think you should wait for an acknowledgement? It is maximum round trip propagation delay. So, from node A it has to go to node B and then the acknowledgement has to come from node B to node A. So, this is a round trip going from one side and then again coming back. If no acknowledgement is received in this time frame, then we resend that frame after it waits for a random amount of time. In Aloha, it waits for a random amount of time before it decides to resend it. And if station fails to receive an acknowledgement after repeated transmission, it just gives up. And channel utilization or efficiency or throughput, that is a measurement, or the matrix, it is the percentage of the transmitter frame that arrives successfully, that is the utilization, or the percentage of the channel bandwidth that will be used for transmitting frames without collisions. So, our aim is to send the frames, use the channel as the maximum to the maximum possible limit, and then there has to be minimum collisions as well. So, in Aloha, the maximum channel utilization is 18%. So, that is the throughput. So, that is the percentage of the transmitter frames that arrive successfully without collision. That was the utilization. And the maximum propagation delay, the time it takes for a bit of a frame to travel between the two most widely separated stations. Please understand, in a network we could have multiple nodes, but two maximum separated nodes, this is the propagation delay, that is the time taken for a bit of a frame to travel between two extremely separated stations. And in the Aloha protocol, we start. So, we are going to discuss through a diagram what happens when two stations decide to transmit data using the Aloha protocol. So, what happens? It start and it set back off to 0. So, we will discuss this back off is for resending issues. This is a kind of a variable which is going to take care of our resending information. It sends the frame and it waits. Why it should wait? Because a frame which has been sent, probability is it has been transmitted successfully to the destination, or it could have been lost on the way due to collision or some other issues. So it has to wait for an acknowledgement. It waits for an acknowledgement. How long? We discussed in the previous slide. Double the time taken for a bit of the frame to travel from node A to node B and back. And if no acknowledgement is received within stipulated time, it increment the backoff. Originally backoff was what? It was 0. So now it has been incremented. So now it checks the backoff limit. If the backoff limit, it tries, see in the backoff limit it was 0, 1, 2, 3, 4, 5. Suppose for example, we as a part of the protocol, we assume that if a packet has not been sent with 5 attempts to stop it. So in the backoff limit, we check the backoff limit. If it has been achieved, we just abort the process, or we wait backoff time. Right. So we wait for a particular amount of time and then again send the frame. And please understand, now the backoff time is not 0. Again this process is repeated time and again. So either it will be aborted or it will succeed. It will abort if the backoff limit has been attained, and it will succeed if acknowledgement is received. Now in Aloha protocol, if the transmission time is t second, then the vulnerable time is 2t second. This means no station should send during the t second before this station start transmission, and no station should start sending during the t second period that a current station is sending. That is a vulnerable time. So during this time, a station, other station, they should wait. Let's see in pure Aloha, that is one variant of over Aloha protocol. See, the greens are the packets or the frames. In the station 1 is trying to transmit some fixed size frames, and station 2 is also trying to send. But somehow station 1 and station 2 are trying to send packets which are not colliding on the basis of their timing. As you can see, the frame in station 2, the frames which are coming out of station 2, they are not colliding with the frames which are coming out of the station 1. And similarly, in the station 3, we see a overlap of frame 2 of station 1 and frame 1 of station 3, and that has been given in the 4th line, which is giving red blocks is complete collision and partial red blocks is partial collision. Partial collision is occurring between frame 3 of station 1 and frame 2 of the station 2. That is the partial collision which is happening. In pure Aloha, frames are transmitted at completely arbitrary time. There is no fixed. Time is divided into slots equal to, in random access slotted Aloha, this is another flavor. Time is divided into slots equal to frame transmission time, that is TFR, and a station can transmit at the beginning of a slot only, not before that, not after this. If a station misses the beginning of a slot, it has to wait until the beginning of the next time slot. And if a center clock or a station informs all stations about the start of each slot, maximum channel utilization 37%. Please see, it is a significant improvement over the previous 18%. Now it is 37% in slotted Aloha. And the danger time over there, it was 2T, now it is vulnerable time is just the TFR, that is the time frame which we have decided earlier. So we have improved throughput, channel utilization 37% in contrast to 18% of the earlier, and the vulnerable time, the danger time is also decreased. Now, in this, as you can see, only complete collision can occur, partial collisions are not occurring in random access slotted Aloha. Why so? Because the slots has been demarcated. A station can start either at the beginning of a slot or the beginning of the next slot or the beginning of the next to next to next and so on. Intermediate, it is not possible. So, as we can see, station 1 and station 3, they are colliding. The second frame from station 1 and the first frame from station 3, they are colliding. Similarly, frame 3 in station 1 is colliding with frame 2 of station 2. So, that is complete collision, not desirable. But see, we have been benefited from the issue that there is no partial collision, and hence the chances or the overall efficiency of our channel that has increased from 18 to 37%. That is the one reason. Advantages of Aloha protocol: a node that has frame to be transmitted can transmit continuously at the full rate of channel if it is the only node with frames. Right? So, a node that has frames to be transmitted can transmit continuously only if it is the only node with frames. It is simple to be implemented. No master station is needed to control the medium. We will see in some next slides, there are some protocols wherein we need some master stations as well. And there has to be some disadvantages as well for this. First disadvantage is, if a node wants to transmit, many collisions can occur and the rate allocated for each node will not be on average RMBPS, bits per second. This causes low channel utilization. This can. So, we have another flavor of protocols which is random access carrier sense multiple access, CSMA. So, carrier sense. So, what does that mean? So, that means if two nodes, two stations, they wish to talk to each other, they wish to exchange some data, the sending node would first sense the carrier, that is the medium. It will try and find out what is the status of the medium. And to improve performance, it avoids transmission that are certain to cause collisions. It has to avoid transmissions, such transmissions that are certain to cause collisions. And based on the fact that in LAN propagation time is very small, LAN propagation time is very small. Why so? Because a LAN is a local area network. So, propagation time is really limited and it is really very small. And if a frame was sent by a station, all stations know immediately, so they can wait before start sending. So, this is applicable in LAN. A station with frames to be sent should sense the medium for the presence of another transmission carrier before it starts sending its own transmission. So, it would be checking the medium and it will try to find out whether there is some signal already residing or being transmitted on the medium. If it is, then it has to wait. So, this can reduce the possibility of collision, but it cannot eliminate it. Why? We will discuss it the next. In this case, collision can only happen when more than one station begin transmitting within short time. That is the propagation time period. One node has put some signal on the medium, but it has not been received by, this traffic is not sensed yet by some other station and it also start sending. So, what is happening is the second station, it is also sending without being aware that some data is already there on the carrier. So, that is going to create problems. In this, we have some another flavor. We have random access. So, previously we had some Aloha protocol. Now, we are discussing carrier sense multiple access and random access flavor of this. Now, this vulnerable time for a CSMA. Vulnerable time is the chances of the time during which the chances of the collision are there, and the vulnerable time for CSMA is maximum propagation time. Please try and understand, in this vulnerable time is not twice the propagation time or the twice the time taken between signal to travel from to farthest nodes. No, it is vulnerable time is the maximum propagation time. The longer the propagation delay, the worse the performance of the protocol because of the above case. So, if it is a big LAN, then the performance can degrade. So, as you can see, so we are having this A, B, C, D. A sends some data, B senses it here, then C senses it here, then D senses. Vulnerable time is equal to the propagation time. So, that is the time taken for a travel between A and D. Now, we have different types of CSMA protocols. So, these further demarcation of CSMA protocol, carrier sense multiple access, carrier sense multiple access. So, we have different CSMA protocols that determine what a station should do when the medium is idle and what a station should do when the medium is busy. So, there could be only two probabilities, either the medium is idle or the medium is busy. It could be either busy or it could be idle. So, no traffic could be there or there could be a traffic. So, we have three flavors of this CSMA. First one is non-persistent CSMA, another is one persistent CSMA, and the third is P persistent CSMA. Now, this persistency, this is English meaning of persistency quickly is the tendency to repeat it, how badly you want this to go. So, it could be non-persistent means there is no tendency to repeat it. One persistent is yes, there is a tendency to repeat it once, and P persistent is we will see in the next slides. But generally speaking, so this is persistency, the degree of persistency could be N persistent, could be 1 persistent, or it could be a P persistent CSMA. And in non-persistent CSMA, a station with frames to be sent should sense the medium. So, it is as simple as that. If you want your car to enter a highway, it should sense what is the status of the highway. The highway could be either busy or it could be empty. Say, this is the two extreme cases. Busy means you cannot use that highway at that point of time from that station, and free is there is no traffic at all. Now, let us see. In this, if medium is idle, it transmit, as simple as that. Highway is free, just let your vehicle enter it. Otherwise, go to step 2. If it is not idle, that means it is busy, then wait. Then the second step of carrier sense multiple accesses. If medium is busy, back off, wait a random amount of time and repeat 1. It's like your car in driving, you're trying to enter the highway from a small street or some sub road. If the highway is busy, then what you do? You wait. How long? A random amount of time. This random amount of time could be randomly generated, maybe 3 seconds, 7 seconds, 9 seconds. After that random, say 9 seconds, again you check the road and then again see. Then repeat the process 1. If the medium is idle, then transmit, otherwise go to 2. And 2 is medium is busy, back off, wait a random amount of time and repeat 1. The non-persistent stations are differential. Differential means they differ, they delay. That means in plain language, that means they are going to respect others. So that means they allow